Hi, it's Wendy again, and this is the third in our series on file I/O, or file input and output in Java. In the first video, we just did an overview of the terminology and of file structure. In the second video, we looked really briefly at some of the API that we're going to use when working with files. In this video, we're actually going to write some code that produces output to a data file or writes to a data file. And in the next video, we'll do the same thing with file input. So we'll write code to read the data in from the file. And then in the last video, I'll just show you some different things you can do with files and with other stuff that you've learned like array lists and GUI and that sort of thing. So as I mentioned in the earlier videos, we're going to be working with plain text files. These are actually called sequential files. There's different kinds of plain text files, but the ones we're going to be working with are sequential files. And sequential files are called sequential files because of some of the characteristics that they have. So as I mentioned earlier, they are plain text, which means they also require delimiters. So for example, this was the employee text file that we had in a previous video, where each record represents or describes one employee, and then each field describes a piece of information about a particular employee. And because they're plain text, we have to use delimiters to separate the fields. So here I'm using commas. And we use the new line characters as a record delimiter. So field delimiters and record delimiters are two different things. Field delimiters separate the fields, and record delimiters separate the records. These are necessary with sequential files because that's how the program knows when it's finished reading one field and can move on to the next field. And similarly, when it reaches the end of one record and can then start reading the next record. So those delimiters in a sequential file are mandatory. They're absolutely important. Another thing about sequential files is that we use character streams to read and write them, and we are required to separate input streams and output streams. So you'll have to create one stream to do the input, and if you want to output as well, you'll have to use a different output stream to do the output. Typically for the input, we use scanner, and for the output stream, we actually use a set of classes nested together, which I'm going to talk about in a few minutes. Another characteristic of sequential files, and this is really where the name sequential comes from, is that they're what we call sequential storage and access. That means that the records are stored in the order in which they are added. So if we look at our example here, this record here, 111, that's the first record that was added, and then the one with ID 222 was the second record added, the 333 was the third record added, etc. So sequential files, not only do they store the data in sequential order, but it's also accessed in sequential order. We call this a forward-only type of access. What that means is that if I want to access a particular record, I actually have to go past all of the records before that one. If you're older and you've ever listened to music on a cassette tape, you'll understand exactly what this is like. In those days, when you wanted to listen to, say, the fourth song on the cassette, you would have to fast forward past the first three songs to get to the fourth one. It's the same kind of thing, except it's a lot faster when you're accessing records in a sequential file. It is forward only. You cannot go backwards. A cassette tape you can rewind, but there's no rewind on a sequential file. If you want to access record 4, you have to go past 1, 2, and 3, read record 4 and do what you want. And if you want to go back to, say, record 2, you actually have to close the input stream and reopen it. So you start at 1 and then read past 1 to record 2. So typically when you read records, you have to go forward. If you want to go backwards, then you'll have to close your stream. I know this sounds like a pain. You're like, that's useless. But remember, when you're working with data files in an application, you're typically only reading the data in once and storing it in something like a list. And then you're just accessing the list all the time, because you can directly access a record when it's stored in a list. So that's usually what we do. We'll talk more about that actually in the last video in this series. If you wanted to see some code, this is just pseudocode, but if you wanted to access the fourth record, you would have to connect a stream to your file, and then you'd need some mechanism to count through the records to get where you want to go. So here I'm using a counter variable with a while loop. So I start my counter at 1. And then while my counter is less than or equal to 4, I read a record, and I actually don't do anything with it. I just toss it. And then I increment my counter. So the first iteration, I read record 1, and then increment my counter to 2. And in the second iteration, I'm going to read the second record, increment to 3, etc. until I get to 4. So when I read that fourth record, I'm going to increment my counter to 5. My while loop condition's now false. I exit the loop, and then I can print or process the record in whatever way I want. Again, that is tedious. If you're looking at that thinking, man, that's tedious, good. That's exactly what you should be thinking. It is tedious. And again, this is why we typically don't work directly with the file as we're writing the program code. We typically would load the entire file into some kind of list, access the list while the program is running, and then at the end of the program, we would then spew out the contents of the list and overwrite the data file with all the updated data. But again, we'll get into that in a later video. Today, we're just going to learn the basics. Now, file output involves 3 steps, and we're going to actually code this in just a minute so you can see the 3 steps. So the first thing we want to do is we want to connect an output stream to the file. We are going to talk about output first because we can't really talk about input until we have a file to input from. So we're going to create our file first, and then we'll use this in the next video when we learn how to input. So to just the most basic bare bones writing to a file, you can use the print writer. The print writer is actually not a new class to you. You'll see actually print writer is the class that owns methods like print, printf, and printline. Ta-da! So you actually don't have to learn that much about writing to a data file because you already know all the methods. So that's kind of nice. So what we do is we would create a print writer. There's a couple of different constructors. The 2 that you would probably use most are the one that takes a string. So that can be the name of the file itself as a string, which can include absolute or relative path information if necessary. There's another version that takes a file object. So if you're using the file class to construct a file object for your file, you can do that as well. The constructors always throw an IO exception. IO exception, we're going to talk about this in a later lesson. It's the parent of many different kinds of file input and output exceptions. For example, there's a file not found exception. There's an EOF, which stands for end of file exception. Those are all children of IO exceptions. So you're going to get very familiar with the IO exception class. You'll also notice something interesting about the IO exception, which I'll talk about today and in a later lesson. Now, once you've connected to your file, however you decide to do it, again, this file doesn't have to exist. If you've got a file that doesn't exist, you're just going to create it. And this code does this for you automatically. If this file does not exist, Java will create it for you. And if your program crashes after this, you'll actually see the data file and it'll have 0 bytes on your file system. Once you've created a stream, an output stream to your file, then you actually write the data to the file. So as I mentioned earlier, if you're using print writer, the nice thing is you already know these methods. You can use print, printline, and printf is not used to format like double values and stuff. You would save any double values as they are. You don't want to round them off or anything. What it's for is when you want to add delimiters, it might be easier instead of concatenating your delimiter to your field data, it's better to just use printf. It's a little easier. You'll see when we actually try it out in our code. And then the last step is very, very important, and you're going to see why in our demo. The third step is you must close the file stream, the output stream, when you're finished. You'll see why. It's because when you're working with these kinds of output streams, character streams, it's not writing directly to your file. It's actually writing to an area in memory called a buffer. So it's called an input buffer or an output buffer, depending on what you're doing. In this case, it's an output buffer. So the output buffer, it's pretty big. It's actually bigger than we need it to be, and we're going to deal with that in a few minutes. So what happens is when you use print, printline, or printf, it's saving data to this buffer, And then when the buffer gets full, then it will physically write the data to the file. If you're finished before the buffer gets full and then your program terminates, that data in the buffer is never written. So you always have to make sure you close your stream. Again, I'm going to demonstrate this. I'm going to pretend like I forgot, and I'm going to forget to close the stream, and you'll see. So what I'm going to do is I'm going to write a statement that creates an output stream to a file called example.txt using the printWriter class. So I always call my printWriter variable file out. I don't know why, I just do. You don't have to call it that if you don't want to. As long as it's self-documenting, call it whatever you like. And example.txt. And when you're prompted, you will need to import java.io.printWriter, because that's where it lives. And you'll get this error as well. It says unreported exception, file not found exception must be caught or declared to be thrown. I don't know if you've seen this error before. I'm going to talk more in detail in the lesson on exception handling next week about this, but it's basically saying that it's possible this constructor might throw a file not found exception and you must catch it or declare it. Catching it means put this code in a try block and then add a catch block below it. Declaring it means going up to our main method and adding throws and what was it? File not found exception. Don't type this. So that's what that means. And you're going to have to import that, but I'm not going to right now. So that's what declaring means. I wouldn't worry too much about that right now. I'm just going to do a try block because some of our other stuff is going to throw exceptions as well. And we might actually want to add some stuff in our try catch block. I'm going to put IO exception. It will catch any IO exception or a child of IO exception. And that would include file not found exception. It's in the java.io package. Surprise, surprise. For now, just print a normal stack trace. Hopefully you remember what that is from semester 1, because I actually want to see if there is an error right now. I want to see what it is in full. So we're just going to print a stack trace. Typically, once you're ready to deploy this program, you would replace that with something more friendly. So I've got a printWriter file out. Now the second step is to write the data to the file. So I'm just going to write some random stuff. So I'm going to write file out dot, and I'm just going to try a print, and I'm going to print hello. And then I'm going to do file out, and I'm going to do a print line, world, and then I'm going to do one more print line, and write, whatever your favorite number is. I'll put 7, because in North America, 7 is considered a lucky number. See, in North America, the lucky number is 7, and the unlucky number is 13. But in some countries, it's 4 and 8. I think 8 is a lucky number and 4 is an unlucky number. If I've got this wrong, I know somebody out there is going to want to correct me because it's not something you want to get wrong. So I'm going to use 7, but if you want to use 8, that's okay too. So any number you like. So I'm going to print some stuff and you're thinking, oh, this is exciting. I'm printing to a file. Let's check it out. And I'll show you where your file is stored as well once you run your program. Now, when you run it, you'll just see build successful. And that seems a little weird, but that's okay. That's actually good. If you see anything else, it probably means things didn't work, and you might have to check the stack trace that was output and see what's wrong. But ideally, it should work okay. We didn't tell it to print anything to the console, so that's why it didn't output anything. Where the output went to this data file. At least we hope it did. So to find your data file, you probably remember way back in the beginning, we talked about this projects window, which is the logical view or the structure of your project. There's also this files window. If you don't see it, because maybe you closed it at some point, you just go to window and then go to files and you should see it. So this files window, this is the physical structure of your file, and you'll see actually, there it is, example.txt. So it should be right in the root. Now, if you had done, let's say you want to keep your files in a subdirectory called data, then you could totally do that. In fact, we'll do that in the next one. You need to create the directory first before you actually, well, you could actually do that in code, I suppose. You saw the methods, you could do that, but I like to create it here first. So if you double click example.txt, it will open it and you'll see, oh, so sad, it's empty. And so you're thinking, geez, Wendy, why did you show us this code that's so fabulous and will save data to a file if there's nothing in the file, right? Well, what were we talking about earlier? We were saying that there's 3 steps to writing data to a file. First, you want to connect the stream, then you want to write the data, and then what was the last step? You want to close the file stream. Like I said before, if you don't close the file stream, you run the risk of your data not being saved, because this is only a small amount of data, and the buffer, it's big. It's like, I think on most systems today, it's probably around 4K, maybe more. This is definitely not 4 kilobytes of data. It's a lot smaller. So because we didn't fill the buffer will only physically write to the data file on the computer when it's full. So if you have data in your buffer, it will not get written to the file unless you do either what's called a flush, which I know sounds funny, but you can actually flush. It's the flush method. Or since we're done, we're just going to go file out.close. And closing the stream will flush out any leftover data in the buffer and then close the connection at the same time. So it does both things that we want to do. So when you add that, you can save and rerun your program. And again, you shouldn't see anything in the console except build successful, which is good. If your data file was still open, like mine is, when you flip over to it, it might prompt you and say, this file has been updated. Do you want to refresh your screen? Just say yes. Or it may not. It just depends. So sometimes it does, sometimes it doesn't. But here you can actually see there's my hello world and then the number 7 that I wrote. So notice that when I use print, it's just like print on the console. It outputs whatever you tell it to, and that's it. But when you use print line, print ln, it outputs what you tell it to and then adds a new line to the end. So that's why I get hello and world on the same line and then 7 on a line all by itself. So you're thinking, this is really cool, right? I want to do it again. So now I'm going to say goodbye. And if you want to add a space, you would have to actually type a space in there. I don't want to say goodbye world because that sounds kind of fatalistic. So I'm just going to say goodbye, everyone. Have a great day. And this time I'm going to write the number 10. I don't know why. I just like the number 10 because in hex, it's the letter A. Maybe that's why. And I'm going to run my program again and I'm going to get really excited because now I should see hello world and then goodbye everyone, right? Wrong. I see just goodbye everyone. And you're like, oh no, what happened to my hello world? Where did it go? And this is just how PrintWriter works. When you use a PrintWriter, unfortunately, it's kind of cool because we can use methods we're already familiar with, but unfortunately, it will overwrite the file every single time. If I write, hundreds of bytes worth of data, and then I come back and run the program and put hello world, it'll overwrite the entire file with hello world. So that kind of sucks. So you're thinking, geez, Wendy, why are you showing us this crappy code that doesn't do what we want? Well, we're getting there. So another thing you can do is you can actually use something called a file writer. And a file writer is a character output stream that allows you the option to append. I'm saying the word append, A-P-P-E-N-D. So it'll allow you to append to the file. Append is just a fancy word for add to the end of something. So it allows you to add records or data to the end of the existing data or after the existing data. Now to do that, as I said, we need to use something called a file writer. Oh. But the file writer, unfortunately, you can only write 1 byte at a time. And we definitely don't want to do that. We like being able to use print and print line and later printf to write our data. But that's okay because these stream objects will also take another stream object, which what that allows you to do, it allows you to take the features of different stream objects and combine them together. So for example, one of the other things we're going to add is something called a buffered writer. I mentioned earlier that the input buffer and output buffer, they're actually pretty big. The output buffer is way bigger than we need it to be, which when you're doing a lot of writing, like frequent writing of small amounts of data, it's very inefficient and it actually slows down your program. So if we add a buffered writer, it actually makes like a custom buffer. You don't actually have to do anything special, just instantiate it. But it actually increases the efficiency of the buffering of your output data. So what we're going to do, we're going to use a file writer so we can write to files correctly. We're going to use a buffered writer so we can improve performance with the buffering. And then we're going to use a print writer so that we can use the print and print line methods. So how this is going to work is first we're going to construct a file writer to allow us to append to the file. We're going to take that file writer object, we're going to wrap it inside a buffered writer. What we're going to do is instantiate the buffered writer and pass the file writer into its constructor. Then we're going to take this buffered writer file writer object and we're going to pass that into the constructor print writer. And that's going to allow us to construct a print writer, buffered writer, file writer. So it's basically 3 streams all wrapped around each other. It's kind of like one of those candies that when you suck on it a little while and then take it out of your mouth, it's a different color. And then you put it back in your mouth and you suck on it a little more and you take it out and it's another color. It's because they basically layered the candies different colors and wrap them around each other. That's kind of what we're doing on a smaller level. We're going to take a file writer, wrap a buffered writer around it, and then wrap the print writer around that. It basically layered the candies different colors and wrap them around each other. That's kind of what we're doing on a smaller level. We're going to take a file writer, wrap a buffered writer around it, and then wrap the print writer around that. It's not going to be too complicated. We're actually going to do this all in 1 line of code. You could do it in 3, but I wouldn't. It's not necessary. It uses up memory that you don't really need to use. So what we're going to do, if you don't want to modify this code, if you want to keep it the way it is, you can comment it out and then just copy paste it. It doesn't matter. Just going to get rid of this. Whoops. So what we're going to do is we're going to pass our print writer a new buffered writer. And you don't need to tell buffered writer anything special. You do need to import it though. Again, these are all in java.io. And then you give the buffered writer a new file writer. I will wrap this statement properly in just a moment. And we need to import file writer. And then you give the file writer either the string for the file path and name or a file object. So we'll do that first. I'll do example.txt. And as a second argument, you have the option of specifying a Boolean true if you want to append, or either set it to false or just leave it out completely if you want to overwrite. So this is exactly what we want. We pass it the value true, and it should append our new data. I'm just going to wrap this now. It should append our new data to the existing data. So the last thing in my data file is goodbye, everyone. And so what I'm going to do now is I'm going to go back to hello world and the number 7. There we go, like that. And if I run this again, it will connect to my example file and it will find the end of the file and it will add my new data to the end of the file. So let's cross our fingers. You don't need to cross your fingers. It's going to work. And when I run, everything looks okay because it didn't say anything. And when I go look at my data file, there it is, my hello world. So there you go. You'll probably notice there's an extra blank line at the end. That's because the last thing you wrote to the file was a print line. So it did add a new line to the end, but that's good because that means the next thing you write to the file is going to go on the next available line. So that's actually a good thing. That works. It's exactly what we want. Now, just for interest, there's another thing you can actually do here that you might have seen in your textbook. Remember we were saying that when you create your stream object, you write your data, and you have to remember to close your stream. The other problem could be if something crashes while you're writing and then you jump to the catch block, your stream is never closed then either because you don't reach the close statement. So that could also cause problems with data not going out of the buffer into the data file. So they actually introduced, I forget what version of Java it was, but they actually introduced a new kind of try catch block that you might be interested in. It's called a try with resources. And what you do is you just do try and then you actually add a set of parentheses. And in there, you write the statement without the semicolon that instantiates your output stream. And then you don't actually need the close statement. So what this will do is it basically says, try this code. And if something happens, or if nothing happens, when you're finished, close that resource or close that stream. So it will execute the close either when it jumps into the catch block because it got an exception, or if everything works fine and it actually exits the try block because nothing bad happened and it moves on with the rest of your program. So it's a newer thing, but it's kind of cool. And if you want to test it out, I'm going to add another new piece of data. I'm going to add the name of one of my cats and the year in which I got him, which is 2013. And so now if I run my program one more time, everything looks good, and I go look at my file, I see that the data did actually get written to the file, even though I commented out the close, right? This wouldn't have worked before, but it's because I'm using the try with resources try block. So you put the actual instantiation of your stream in parentheses after the word try, and it will automatically close that resource or close the stream when it either jumps to the catch block because there was an exception, or when it leaves the try block because everything was fine. So it'll close it for you no matter what. So I like this new try block. I think it's really cool, especially because it does the error handling a lot better. So if it does crash while it's writing, it will still output your data to the file, which it wouldn't do before. Now, maybe you don't want to output the data. It is possible that maybe the exception occurred because some of the data was not valid. Well, then you don't want that record going out to the file. So then you would go back to the regular try block, right? It's up to you. It just depends on the situation. But there it is, in case you're curious. It's kind of a cool thing to have. So now that we've learned the actual code that we need to write to a data file, let's take a look at how to actually write records with fields and stuff like that, like we were talking about in the earlier videos. So let's do an example, just a really basic example. We're going to write a little program that will repeatedly ask the user to enter information about products, and then we'll save them to an inventory file. So that means I'm going to need a scanner, and I'm also going to use a file object this time as well. So I'm going to create my file object first, and I'm going to put this in a data subdirectory, which is generally a good idea. So a subdirectory called data, and I'm going to call it inventory.txt. I'm going to need a scanner for my input, my user input, so I'm just going to do that now. And just got to import these things because I took the imports out when I was doing something else. There we go. And just to help you remember about closing the stream, I'm going to go back to the original try catch here. Don't worry about that. It needs one of those. There. I'm going to try and switch between the two whenever we do examples, but I'm going to go back to this one for now. And then for your file writer constructor, instead of saying example.txt, I'm going to put file, because this time I'm going to work with the file object. So I'm going to get rid of this. So what I'm going to do, I just want to repeatedly ask the user to enter inventory data and save each section of data as a record, nicely delimited in my file, until they're done. So obviously when we do one of these kind of console programs, like please enter data until you're finished, we like to use a char. So I'll just initialize it to a Y. It's actually not going to matter what I initialize it to because I'm going to use a bottom checking loop. Just because it's easier, but it doesn't matter. You can use a top checking loop because this acts as a priming read, so that's fine. So in my do while, what I want to do is I want to get the data from the user using my scanner. So I'm going to say enter product ID, and then I'm going to make a string called prod ID and use in.next because they won't have spaces in them. I'm going to ask them to enter the quantity. I guess I should be consistent here and use a capital P there. And I'll do that as an int. .next int. We haven't done this in a while, eh? Used a scanner. And then I'm going to ask for the, what was the other thing? The price. And I just noticed I want all of these to be print and not print line because it looks prettier. All right, and it'll fit better on the screen. Double price. Now I'm skipping all of the error handling, the data input validation. I'm doing that on purpose because I want to focus on the file output. But ideally, you would do data validation. You shouldn't save invalid data to a file. But on the other hand, when we learn how to read the data in, we'll say, don't assume the data in the file is valid. So, you know, it means you're being careful on both ends, which is always the way it should be. So you shouldn't save invalid data to the file. Sometimes it's going to happen anyway. So when you learn how to read the data back, don't assume the data is always valid. Yeah, I know it's a drag. It's just the way it is. You don't know what kind of idiots you're going to end up working with in the future. They may have crappy data validation, right? Even though they should have good data validation. You just never know. So ideally, just so you don't forget, I'll put a big to-do here. Data validation. Must do that. We're going to actually cover that in the lesson on advanced exception handling, so don't worry. So now that I have the data, hopefully, for one record, I now want to write that one record to my file. So this is where printf comes in handy. So you can do a little printf, and what you do is, you know that you're going to have a delimiter. You probably could use a comma here. I just like to use the pipe symbol. I don't know why, I just do. Now here's what's interesting. So I'm going to write a string field and then delimit that from the next field with the pipe symbol. You can do the %d or you can use %s, because here's the thing about sequential files. Everything is stored as a string. This is going to be a bit of a pain because when you do learn how to read this data back, you're going to have to read it all as string data and then parse it somehow into whatever data type it should be. And I'll show you a couple of different ways you can do that. Some are easier than others. But when you write the data, you could technically write it all as string data. I am going to use the proper format specifiers because it means I can just put quantity in here as an argument with %d and it'll go. If I don't do %d and I put the quantity in there, it's going to tell me I'm using the wrong format specifier, right? Because it's an integer, so it's just easier. I wouldn't format your double value. If you've got any floating point data, leave it in its raw form. Do not save formatted values to your file unless you're actually told to do that, and you generally won't be. So just save the data in its raw form. It's not going to be funky anyway, it's okay. And then I'm just going to put prod ID and then quantity and then price. If you're taking notes, make sure you write that down. Always save your floating point data in its raw form. Don't format it or round it off or anything. So I connect to my stream and then I repeatedly get data and write that data. Oh, you know what I'm missing? I'm missing a record delimiter. I've got my field delimiters, but I'm missing the record delimiter. When I'm using printf, I use %n, but if you're using print or printline, well, if you're using printline, it's going to already add a record delimiter. If you're using print, then you have to put a new line in there. So I'm repeatedly writing each record, and then when the user wants to quit, they're going to say something that doesn't start with a Y, right? So again, equals, oh, I should ask the user first. Do you want to add another? Again, like always, if they don't enter something that starts with a Y, we're going to assume that's a no. And I like uppercase, but if you did lowercase, that's okay too. I just like uppercase because I can read it better. I have really bad eyesight. So if the user says anything that starts with a Y, we're going to assume they're going to continue. And then if they enter something that doesn't start with a Y, we're going to assume that's a no. And then we're going to quit, at which time we'll close the stream. So let's run it, add some records, and then we're going to take a look at our file. Oh, you probably want to add the data directory here first. Just right click on in your files window, not the projects window. Don't manipulate files and directories using the projects window because things will not end up where you think they're going to end up. Go to the files window, right click, and just go new folder, call it data. There you go. That's where your data file is going to go. Crossing your fingers. That all goes well. All right, so in the console, I'm going to just make up some product IDs. So ABC1234 or 1344, whatever works. And then enter quantity. So 25 of something that's $2.99 each. Yes, I'd like to do another one. And product ID ABC3333. And I'm going to have 10 of these for $14.95. And I'm going to do one more. So yes, one more. And then product ID ABC and then 77777. And how many? 100 of something that is 99 cents. And now I'm going to say, nope, don't want to do any more. It's like, okay, cool, goodbye. And if I look inside my data, there's my inventory txt, and there's my records. So this is how the data is actually going to be stored. So you'll see I've got each of my fields delimited with the pipe symbol, and then each of my records is delimited with a new line, which obviously you don't see the new line characters, but you see the effect of the new line characters because every record is on its own line and it's ready and waiting for more. In fact, if you want to run your program again and add another record, you totally can. So if I enter product ID ZZZ, and then 1111 and 55 of something that costs $10. And do I want to do another one? Nope. And when I go look at my inventory, there it is. Ta-da! So now you know how to output to a file, which involves creating a file in some cases as well, and how to add proper delimited records and fields to your file. So now that we've got a file, what we're going to learn how to do in the next video is how to read that data into the program so we could process it. You can count the records, you can calculate totals or averages, whatever you like. Make sure you go into the notes for this lesson and do the practice exercises. There's actually a really good one with evaluations and grades. I actually give my Java 3 students an assignment with that kind of same concept, but they're creating a homework tracker using a database. So you might see that again in your future. Anyways, do the exercises, and the next video will be on file input. So I'll see you there. Thanks for watching.